Hi, in this lecture video, I'll be discussing the ionic bond model, which is unique in the sense that it involves the transfer of electrons between atoms. So we see that ionic bonds are those that are formed due to the electrostatic attraction between the cations and the anion. So anytime we see cations and anion attracting each other, the bonds that they produce would then be the ionic bonds. And substances or compounds that are formed by the ionic bonds among the ions are then called the ionic compound. And ionic compounds are normally formed between metal and non-metal, but then this is not always the case because we actually can also have ionic bonds that involve non-metal as well. And that is what we see in polyatomic ionic compound that we'll discuss later. But for now, let us stick to ionic bonds as the bond exists between metal and non-metal. And since the metal wants to lose the electron and the non-metal wants to gain electron, they will then interact very favorably with each other to exchange electron, and both of them then become the ions. And the ions then attract each other electrostatically and therefore producing the ionic bonds between them. For an example, sodium and chlorine. If we ever allow sodium atom and a chlorine atom to come in and interact with each other, these two elements right here would then produce an ionic compound. For an example, let's now consider all of this. So let's say here the sodium, and in this diagram right here, we are showing all of the valence orbital. So in this case right here, the sodium on its first principal shell, the 2 valence electron. And on the next principal shell, the second principal shell, there are 8 electrons on it. And on the third principal shell, there's 1 electron on it. And the electron configuration of sodium, you can see that we have the neon core followed by 3s1. And as for the chlorine, so these are the electrons on the different principal shell of chlorine. And the electron configuration is that they have neon core followed by 3s2 and 3p5. So that's the electron configuration of these two elements. So here in this case right here, we will then see that sodium has 1 electron, valence electron. And in fact, it have 1 valence electron more compared to neon. And so it wants to have electron configuration similar to the noble gases. And here in this case right here, I have 1 valence electron. And this is 1 extra electron than neons that it doesn't want. So therefore, sodium has strong incentive to give its 1 valence electron away. And now when we look at chlorine, so chlorine has 7 valence electrons. And we can see that it is 1 electron away from having the same amount of electron as a noble gas. So in this case right here, so this is 1 valence electron less than a noble gas. So we would then see that chlorine would then have a strong incentive to gain another electron. So therefore, when sodium and chlorine are allowed to interact with each other, sodium will be happy to give its electrons to chlorine. And therefore, this is what the consequence would be. After sodium have given its 1 electron in a 3s orbital, it will be able to get rid of its third principal shell. So now it can claim that its second principal shell was then its valence principal shell. And here in this case right here, you have 8 valence electrons. So that's how sodium become an octet by giving it 1 electron in the 3s orbital away. So now it becomes isoelectronic to neon. So isoelectronic to neon. And the same term isoelectronic mean iso again mean equal or same. And electronic here refer to electron. So we have same electron configuration as neon. So this now producing sodium ion. And this is our cation right here. As for chlorine, when it gains the electron, it will now become -1 because it will neutral with the 7 valence electron that it has, When they gain one more, it now becomes -1. And this is now the anion. And as for the electron configuration, it now becomes the following. Neon, 3s2, and now 3p6. And this is also the electron configuration of argon. So once chlorine has gained another valence electron, it now becomes isoelectronic to argon. So now we have the argon electron configuration, and it's happy as well. So those are the reasons why sodium would like to give the electron to the chlorine, and the chlorine will be very happy with the electron that it has gained. But as the consequence of transferring this electron, sodium is now becoming positive, and the chloride then become negative. And now we know that whenever we have opposite particles or charges that are opposite to each other, positive and negative, and they attract each other. And this is basically what that ionic bond is. The ionic bond is the bond that is due to the electrostatic attraction among the ion. So that is what happens in an ionic bond when a metal is allowed to interact with a non-metal. Now, so let's now go over how do atoms from the different groups become isoelectronic with the noble gases. We have seen already that group 1, sodium earlier, it becomes isoelectronic with a noble gas by by losing or giving an electron away to become the cation. And as for the chlorine, it becomes isoelectronic with a noble gas by gaining one electron. So let's now go over some of the trends that we can observe from the periodic table. So in this case right here, group 1 element, they tend to lose or give away one valence electron. So as they become isoelectronic with noble gases, they are now producing +1 cation. As for the group 2 element, they are still metal. So in this case right here, this will be the group 2. And we can see all of these group 2 elements right here are now producing the +2 cation because they tend to give or lose 2 valence electrons. And now they're producing +2 cations. And that happened to all of the group 2 elements. Just like the group 1, all of them, when they become isoelectronic with a noble gas, they now all become +1. And now move on to group 16. In group 16, this is where they are, group 16. Group 16 has 6 valence electrons. To become octet, they would like to gain 2 electrons. So therefore, they tend to gain 2 valence electrons. And therefore, they become -2 anion. When they become monoatomic ions to become isoelectronic to the noble gases. And similarly with the group 17. Based on this table, we see that all of the group 17 are becoming -1 anion. And now the hydrogen behave chemically similar to the group 17 as well. So in this case right here, they tend to gain only 1 valence electron because they're 1 electron away next to the noble gas. So therefore, they produce -1 anion. So these are basically how atoms from the different groups become isoelectronic with the noble gases. These are the charges that they will be adopting. And over here, we see group 15, and group 15 also produce -3. Now, so the reason why that element on this right side right here are for the most part being classified as non-metal, it is because for them to become octet or isoelectronic with the noble gases, the best thing for them to do is by gaining electron, because they have electron 1 or 2 or maybe 3 electron fewer compared to the noble gases. So therefore, they like to gain electron to become octet. And that's why that the non-metal exists over here. Versus for the cations or the metal, they exist on this left side right here because they have 1 or 2 or maybe 3 electrons more compared to the noble gases. So therefore, if they were to have to gain electron, they have to gain so many electrons to become octet. So thus it thus easy for them to give the electron away. So give electrons to become octet. And that's why that metals like to give up the electron, or element on this left side right here, they behave as metal.